Okay, so what I figured I would do to go over some of the speed and velocity problems was I figured I would go over the problems that I assigned you under the speed problems worksheet. So the first question, so this is number one, says what is the speed of a rocket that travels 9,000 meters in 12 seconds? So you'll have to give me a little bit of a break here. I'm trying out a new program. I'm having issues writing on the iPad with this. So 9,000 meters in 12.12 seconds. So what the first thing you need to do here is figure out what equation you're going to use. So the equation that we should use for this should be velocity equals distance, having problems, divided by time. And we're looking for this as the speed. Speed and velocity are interchangeable here. So I'll actually even erase the velocity and write speed. So speed equals distance over time. So for the first problem, we'll take the distance, which is 9,000 meters, and then the time is 12.12 seconds. So notice first I wrote out the equation, second I plugged the numbers in, and then finally I will solve it. And I'm just going to do this on my calculator that I have right here. So I do 9,000 divided by 12.12, and you should get something that looks like 742 we'll call it 6. 742.6, and that is in meters per second. So that's the first problem. So hopefully you got that for an answer. So I'm going to move on to number 2. Number 2 says, what is the speed of a jet plane that travels 528 meters in 4 seconds? So notice I'm looking for speed, so once again this is going to be speed equals distance over time. Plugging in what our speed is, what our speed equals question mark. This is actually how I really like to do this. Distance equals 528. I just made a mistake here. I'll try 528. And time equals, what did I say, 4 seconds? What we tend to find is that on most of these word problems, the hardest part is actually setting up the problem. So if you write out what each part of the equation is over here, then that really kind of helps you just figure out what you have and what you need to do. So what I like to do is just read through the problem. So I said, what is the speed? Okay, so that's why I put the question mark there, because that's what we're looking for, of a jet plane that travels 528 meters, so that's a distance, and then 4 seconds is a time. So that's why I plug those in. Now, to write those into the equation, right, S, because we don't know what that is, equals 528 meters divided by 4 seconds. So that's us plugging in the numbers into the equation. And once again, I'm just going to solve this with the calculator. 528 divided by 4. So S equals 132 meters per second. Okay, so that is 2. I'm going to go ahead and erase this one. I'm going to skip ahead a little bit. We'll say we'll go to number 5. Number 5 says, how long, okay, so that means our time is the unknown. So that's our question mark. Will your trip take in hours if you travel 350 kilometers? So that is a distance, so 350 km. At an average speed of 80 kilometers per hour. So speed equals 80 km per h. So here's what we have for this. There are really 2 different ways to do this. You can either flip around the equation before, or you can just plug it right into the same equation and then manipulate the equation. I'm going to go for that route just so I can show you. So once again, this is speed equals distance divided by time. So our speed is 80. I'm just going to write the numbers here because I don't have tons of room. So 80, our distance is 350, and our time is the thing that we're solving for, so we don't know what the time is. So then we have to do a little bit of algebra. So the first thing we have to do is get that t, this, out of the bottom. Right now it's in the bottom. It's no good for us over there, so what do we have to do? What I would do is multiply both sides by t. Okay, and then these will cancel out, and then you are left with, I'll do it over, I guess I'll do it right here. 80 times t equals 350. Now, what's going on with our t? Well, right now it's being multiplied by 80. So if it's being multiplied by 80, we need to go ahead and divide it by 80. Whatever you do to one side, you have to do the other. That side cancels out. So you're left with t equals 350 divided by 80. So I'm going to put that into my calculator. 350 divided by 80. So you should get 4.375. And this was in kilometers per hour. So this is going to be 4.375 hours. So that's one where it's a little bit more complicated than the other ones that we've been dealing with. Let's do one more. Let's do one where we're solving for the distance. So let's do number 8. So 8 says how far, so that tells us right off the bat that our distance is the thing that we're solving for. In meters, will you travel in 3 minutes? Well, 3 minutes is a time, so let's write that out. Running at a rate of 6 meters per second. So here, our rate is 6 meters per second. So once again, same equation, speed equals distance over time. And this is really easy right now when you only have one equation. As we get to a little bit further on, then you're going to have to pick which equation to use because we'll have multiples. And I'll give you a formula sheet eventually when we're starting to do more different types of problems. So that way you'll have a bunch of formulas to pick from, and then if you write it out like this, then that makes it much easier when you actually do have to pick a formula, because then you know what variables you need. Anyway, going back to this problem. So the distance is the thing that we don't know. So speed equals 6 meters per second equals d divided by the time here is 3. That should be seconds. Let me erase that. So now, the distance is being divided by 3 seconds, so I want to multiply by 3 on both sides. That over here will cancel these two off, so you will be left with d equals 3 times 6, which we don't need the calculator for that one. That will give us 18, and the thing we're solving for is the distance, so that's in meters. So the distance equals 18 meters. So there we go. We just solved for each one of the 3 possible outcomes here. We did one where we were solving for distance, we did one where we were solving for time, and we did 1 or 2 where we were solving for speed. So every different possible configuration that we could have for this equation. Alright, so stay tuned. Lots more problems coming your way, unfortunately or fortunately, depending on how good you are with these. But we will get through it.